In this video, I'm going to walk through the Unit 6 Lesson 10 practice problems. So number 1 says select all equations that are parallel to this given line. So remember that for parallel lines, what we're looking for is that the slopes are the same. So maybe you can figure out how to do slope from standard form by thinking about how you would manipulate the equation to get y by itself. So if we were kind of trying to do this in our heads, we would be subtracting 2x from both sides. So we would get a negative 2x. And then we would end up dividing by 5. So we would get a slope of negative 2/5. If that doesn't really make a lot of sense to you to be trying to do it in your head, you can write it down. So subtract 2x from both sides. So we end up with 5y equals negative 2x plus 8. And then divide by 5 to everything. So then you will end up with the slope-intercept form of y equals negative 2/5 x plus 8/5. And then this is your slope of the line. Okay, so however you end up determining the slope is fine. And so then we just want to come up with which of these lines has the same slope in order for the lines to be parallel. So we certainly can see that this one does not have the same slope because it's positive 2/5. This one does have the same slope because it's negative 2/5, so that line is parallel. This one is in point slope form, so y minus the y coordinate equals the slope times x minus the x coordinate. So the slope is positive 5/2 here, which is not the same as negative 2/5. This one, the slope is negative 2/5, so that one is parallel. And then we have another equation in standard form. So for the slope, we would get the opposite of this term because we'd subtract it over to the other side, so negative 10, and then we'd end up dividing by the 5. So our slope here is going to be negative 2, which is not negative 2/5. And again, you could write out your work for this and subtract 10x from both sides. That's how I got the negative 10x on top. And then divide by 5. So that's where that 5 on the bottom is coming from. And simplifying, so negative 10 divided by 5 is negative 2x. And then 40 divided by 5 is 8. Negative 2, definitely not the slope we were looking for. So remembering in this one that parallel means equal slopes. All right. In this one, we want to prove that ABCD is not a parallelogram. And remember, parallelograms will have opposite sides being parallel to one another. So we're going to want to be looking at slopes in this one again. And so these two flat lines here, so this line and this line definitely have the same slope because they are horizontal lines. So the slope of these two is 0. And so now we want to look at the slope of AB and DC to show that they are not the same. So let me get this, and we'll do our slope triangle here. So our rise over our run. And I'm just going to draw it below this one so that it doesn't go inside of the shape. And then go ahead and count 1, 2, 3, 4, 5, and 3 for this one. So the slope is positive 5/3 since this one is going up. So the slope here, 5/3. This slope is going up as well. So this is going to be a positive. So we'll count the rise, 1, 2, 3, 4, 5. And the run in this case is 4. So the slope of this one is positive 5/4. So BA, so segment BA is not parallel to CD, so it can't be a parallelogram. Number 3, write the equation of a line that passes through this point and is parallel to a line with these intercepts. So we've got two things going on here. So we've got the point that we're going to be plugging in. So here's the point that it goes through. And then we need to figure out that it is parallel to this line. So parallel to a line with this x and y intercept, which means that we're grabbing the slope from there. So we already know this point. That's going to give us our h and k to plug into point slope form, but we need to figure out the actual slope that we want. So let me just draw a quick picture of this. So this one has the x-intercept at 3, 0. And then it's got the y-intercept at 0, 1. So you could just look at a quick sketch and think about the rise, which is 1, and the run, which is 3. So that would be the little slope triangle that connects this line. So there'd be a line in here. And so this line is going down. So the slope here would be -1/3. So we're going down left to right. So slope -1/3 using this point. You can also think about subtracting the y's and subtracting the x's. So when we subtract the y's, we get our rise. So 1 minus 0 is your rise of your slope. And then we can look at subtracting the x's for the run. So I did 1 minus 0. So now I'm going to do 0 minus 3, which gives me -3 for the run. And so still gets me that slope of -1/3. And then we want to be parallel to that. So we want to be using the same slope. So we're going to go over to point slope form. We're going to plug in the point -1, 2, and we're going to use the slope of -1/3 so that our line is parallel. So y minus the y coordinate equals the slope times x minus the x coordinate. So the y coordinate of our point is 2. The slope of the line is -1/3. And our x coordinate of the point is -1. So we end up with that equation in point slope form. All right, then this one, number 4, just gives us a slope. So write the equation of a line with a slope of 2/3. And then that goes through the point -2, 5. So we'll just plug all of this stuff into point slope form. So y minus the y equals the slope times x minus the x. So y coordinate of our point is 5. Slope of our line is 2/3. And x coordinate of the line is, or x coordinate of the point it goes through is -2. So it'll flip to +2. So y minus 5 equals 2/3 times x plus 2. In number 5, this one gives us 2 equations. So it says Priya and Han each wrote an equation of a line with a slope of 1/3. So both of them have to have a slope of 1/3. And they both have to pass through the point 1, 2. So Priya's equation is this: y minus 2 equals 1/3 x minus 1. And Han's equation is 3y minus x equals 5. Do you agree with either of them, and explain your reasoning? So we can take a look at Priya's equation here and say she has y minus 2 equals 1/3 x minus 1. So hers is in point slope form. And so we can see that the y coordinate that she used was 2. And the x coordinate that she used was 1. And the slope that she plugged in is 1/3. And so all of that stuff matches. So slope of 1/3, or point that it goes through, is the point 1, 2, which is the given information. So this one certainly is a true statement. So then let's take a look at Han's. So 3y minus x equals 5. So a couple different options here. So this one obviously isn't written in point slope form. We can solve it for slope intercept form, which remember is y equals mx plus b, and we'll be able to see if the correct slope is in there. And then we can check on the point by plugging it in. So if we add x to both sides to get the y by itself, we'll end up with 3y equals x plus 5. And then dividing by 3, we'll see we will get that 1/3 for the slope. So we end up with y equals, there's a 1 up here, so this is 1/3 x plus 5/3. So we do have the slope of 1/3, so that's good. Okay, now we just need to figure out if this point 1, 2 is actually on this line. So go ahead and plug that in either to this one, the points or the slope intercept form, or to this one. I'm going to plug it into the top one so I don't have to deal with fractions. Okay, so from this given equation, I'm going to plug in the y. So 3 times y minus the x should equal 5. If it does, this point is on the line. So the y coordinate was 2. The x coordinate was 1. So we get 6 minus 1, which is 5. So this point is on the line. So we do have the point on the line and the correct slope. So both equations are in fact correct. Match each equation with another equation whose graph is the same parabola. So these ones on the left side are written in this kind of like directrix form. And then the ones on the right are written in vertex form. So vertex form is y equals a number times x minus the x coordinate of the vertex squared plus the y coordinate of the vertex. So when you were rewriting in vertex form, this x component matched in both. So this was unchanged. So this part should be the same in both equations before manipulating. So if you want to kind of narrow down your solutions here, so we should see the x minus 2. And if it doesn't say x minus 2, it doesn't match with it. So number 1 definitely doesn't go with A. Number 1 could go with B. Number 1 does not go with C, could go with D. So B and D both have that x minus 2 part. And number 1 and number 2 both have that. So these are 1 or 2. So if we're kind of narrowing it down. And then 3 and 4 have the x minus 3. So part A is either 3 or 4, and part C is either 3 or 4 because they share that x part. So just narrowing down solutions so that you can kind of figure out your options here. So then if we go ahead and take a look at some other things, this 1/8, so the number out front here is going to impact the width of the parabola. So the more you divide by, so this is divided by 8, the wider your parabola is going to be. So this 1/12 is going to be wider than the 1/8. So if we take a look over here, and now we're just looking at B and D, which one of these would be wider? Would be the one that's further away from the directrix. Okay, where the focus is further away from the directrix. So in this one, we have a focus of 2, 3, and our directrix is -3. So how far is this point away from the directrix? 3 to -3. This is 6 units away from the directrix. And we could look at this next one. The focus is the point 2, 2. And the directrix is the line y equals -2 from right here. So how far is this one away from the directrix? So this one is 4 units away from the directrix versus this one's 6. So B is actually wider. So B is the wider one. So B must go with 2 and D must go with 1. Then we could apply kind of the same idea for this next set. So this one, 1/4 and 1/12. So this one is wider because it's being divided by 12 versus 4. So then we could take a look here at finding the directrix and the focus. So the focus is 3, 2. And the directrix here is y equals 0. So the distance from this focus to the directrix is 2. Here we have a focus of 3, 4. And we have a directrix of y equals -2. So this one is 6 units from the directrix and focus are 6 units apart. So this is our wider one. So this is number 4, the wider one. And then this would be number 3, the less wide one. So that's one way that you can kind of match those up. Another way would be to multiply and get all of these in vertex form. So whatever strategy you would like to use is fine. Let me do one. I'll do one where I multiply it out into vertex form in case that's what you were wanting to do. So if we do x minus 2 squared plus y minus 2 squared equals y plus 2 squared. So in these ones, you leave the x minus 2, you leave the x binomial alone, and you multiply out the y binomials. So this would be y squared minus 4y plus 4 equals y squared plus 4y plus 4. Then we want to get all of the y terms on the same side. So we'll subtract the y squared. We'll add 4y. And we want to leave the number there. So we have x minus 2 squared, 0, 0, and then we have that plus 4. Y squared minus y squared is 0, 4y plus 4y is 8y, and then we have that plus 4. So we want y by itself, so we'll subtract 4 from both sides. So we get x minus 2 squared equals 8y. So then we would divide by 8 to both sides. And this is where you see the 1/8 coming into play. So we would get y equals, I'm just going to put the y by itself over here, 1/8 x minus 2 squared. So this was this bottom one and it matched this top. So you could multiply out to vertex form in all of them as well. Okay, in this one it says a parabola is defined by the set of points the same distance from a point and a line. So the point being the focus and the line being the directrix. So you could write the equation here just to be plugging it in. And so here's the equation that we can use. So y minus the directrix squared. So that's the distance to the directrix when we subtract the y coordinate and the directrix, should equal the x minus the x of your focus squared plus y minus the y of your focus squared. And so this is our x coordinate is -1 here and our y coordinate is 3. So this equation should be true for this whole problem. So if we do our y coordinate, and now this xy would be the point in question. So we would have our y coordinate 3 minus 5. So we're just going to plug into this equation. Should equal our x coordinate -1 plus 1 squared plus our y coordinate 3 minus 3 squared. So just taking the xy and plugging it into this equation we just wrote. And then simplifying. So 3 minus 5 is -2. And then negative 2 squared is 4. Negative 1 plus 1 is 0. Squared is 0. 3 minus 3 is 0. Squared is 0. And you can see that this is the exact same point as the focus. So it's not going to be away from the directrix. It's the exact same point. So you could have just not plugged that one in. Next one. So we'll take, again, the y coordinate minus 5 squared equals the x coordinate plus 1 squared plus the y coordinate minus 3 squared. So just plugging back into this equation. 5 minus 5 is 0, squared is 0. So this one is actually on the directrix. So we could say, nope, not going to happen for this one. Since it's on the directrix, you can keep plugging it in if you want to. 3, 0. So 0 minus 5 squared equals x coordinate 3 plus 1 squared plus the y coordinate minus 3 squared. So 0 minus 5 is negative 5, squared is 25. 3 plus 1 is 4, squared is 16. 0 minus 3 is negative 3, squared is 9. 16 plus 9 is 25. So this one is on the parabola. And then the final one, so our y is 0 minus 5 squared. X is 0 plus 1 squared. Y is 0 minus 3 squared. So we get negative 5 squared is 25. 1 squared is 1. 3 squared is 9. 1 plus 9 is not 25. And then number 8 asks about transformation rules. So for each rule, describe whether the transformation is rigid, a dilation, or neither. So dilations are when you have multiplication by the same number. So let's take a look for multiplication. So we see multiplication here, but it's not multiplied to both. Here we see that we're multiplying by 2 to both. So this one is going to be a dilation. And I guess I don't need to circle it. We're not like, it's not multiple choice, but this one's a dilation. And then we don't see any more multiplication. And now when you have multiplication, but not to both, then this is going to be neither rigid nor a dilation, because multiplication will change the size. And rigid means that they're the same size. So this would be changing just the horizontal. So this is going to be stretching it by a factor of 2, but it's not going to stretch the vertical. So it's going to be distorted. So this one's going to be neither. And then if all we see is adding and subtracting, these are both translations. So this is going to be rigid. So these are going to keep the same size here.